Hello and welcome to this episode of Math with Martinez. In today's video, we are continuing our discussion on solving our rational equations, but now we're using the least common denominator. And we're going to turn to the second page here and look at multiplying each side of the equation by the least common denominator and then solving that resulting equation. Now, why would we choose this method over the other? Well, do you see here in example number 7 that on the left side, there are actually a couple things, right? It's not condensed like it is over here to just one ratio, but I've got two different things that are being, in this case, subtracted. And so if you have this kind of scenario, it's really wise to use this least common denominator approach. And here's what that least common denominator approach requires of us. What we want to do is we want to take this whole equation and multiply it by the least common denominators possible. So what is the least common denominator? Well, it is the smallest common multiple of all of the denominators. So looking at the denominators, we've got denominators that have just a number, and we've got this one denominator with an n. So what's the smallest common multiple of 3 and 6? Well, that's just a 6. That's the smallest multiple of them both. And what's common to n is just n. So you're kind of just multiplying by that on to every single term. Every single term is going to get multiplied by 6n. So what does this look like? It looks like saying 6n times 4/3. 6n times 4/3, well, it's just multiplying the numerators, which are going to give us 24r over 3. And then the next term, we're going to be subtracting. When you multiply those little puppies together, that's going to give you 42n over n. And then last of all, we're going to have 6n. That's all it'll be in the numerator because it's multiplying by 1 over a 6. Now, what is the beauty of this? Ladies and gentlemen, the beauty is that these little ratios all simplify and will no longer have denominators because 24 divided by 3 is 8. So this simplifies to just 8r. Then I'm subtracting, well, an n divided by an n, sorry, I didn't mean to exactly erase that, but an n divided by an n is going to cancel, and so we'll just have your 42. And then a 6 divided by a 6, that's also going to simplify to a 1. So we're just going to have this n. And so we've got a I'm sorry, that's supposed to be an r. Yeah, this is an n. Sorry. They looked like r's for a second. My bad. So now this is a very, very basic equation that we are beginning to solve. And we can do that by just subtracting 8n on each side. That gives us negative 42 equals a negative 7n. Then just dividing by 7 on each side. And that gives us that the value of n that makes this true would be positive 6. And is it okay if I went and plugged that 6 in right here, the only place where there is an n in the denominator? Yeah, no problem. I can have a 6 in my denominator. Absolutely. So our solution is 6. Voila, that is all. That is using the least common denominator methodology. Let's do another one. All right, so right now we've got this 2 that is over 1. And oh, look at this really unique denominator here. Do you see this one? This little guy, what we would want to do is make sure and factor it first. This is actually a difference of squares. If you factored that denominator, it would look like this, right? So we want to keep that in mind now as we begin to rewrite this and multiply by the least common denominator. So what denominators do we have? Well, I'm noticing here that we have a p minus 2. We have that twice. Then we have a p plus 2 and a 1. So we're just going to have to multiply by a p minus 2 and a p plus 2. We're going to do that to really this whole entire equation. Let me just do it like this so that we can see that everything's going to get multiplied by that. I don't really have enough space to write it out like I did above. So we're going to multiply every single term like that. So what does that mean? Well, we're going to have p. I'm taking both of these and multiplying it to the first one. So p, that was what was there, times the p minus 2, p plus 2. That's all over a p minus 2. Add to that, right here, we're going to have a 2 times p minus 2, p plus 2. Right here, we're going to have now equals the 8. Oh, yes, and this was all over a 1, right? For that second term, that 2 was over 1. Nothing in the denominator there. Now this is going to be an 8 times the p minus 2, p plus 2, all over that denominator, which we said we could rewrite, instead of it being a difference of squares when factored. Looks like this. Now, do you see how this is going to simplify so nicely here? I've got a p minus 2 and a p minus 2. So all that's left here in that first little expression is p times p plus 2. Then we've got in our second 2 times the p minus 2, p plus 2. And in the last, we've got a lot of simplifying that happens. That all just equals to 8. No more denominators. Yeah, buddy. Okay, so now let's simplify a bit. This is going to be a p squared and a 2p. Right here, this multiplies, and so I'm going to have a 2p times a negative 4, but all that is still multiplying with a p plus 2. So we'll have to now we multiplied the first 2, now let's multiply the result of that and the last one together. Still got my p squared, 2p. Now what do we have? This is going to be a 2p squared. And then plus a 4p minus a 4p minus 4. All equal to 8. Okay, I'm noticing here that I have a 4p minus a 4p, so those are going to cancel out. And I've got some terms that are going to combine together. I've got a p squared and a 2p squared, which are going to add up to be a 3p squared. And then after that, I've got my 2p. And then at the end, that minus 4, all equal to 8. Now this is quadratic, so I do want everything on one side. So I'm going to go ahead and bring this over so that I have subtracting 8 on each side, a 12. So a minus 12. Oh, I am so silly. I made a mistake right here, guys. What was this number actually supposed to be? Oh, man. I'm sure you already caught that, but I just caught it right now. The 4, I forgot to multiply the negative 4 times the 2. That would be an 8. So I'm saying a negative 8 minus 8. This should be a 16. My bad. I'm sure you already saw that, but thank you for being patient with me until my eyes realized my mistake. Okay, So now we've got to factor, so I'm going to use my little box right here. All right, just about there. Let's put those values in our box. Got a 3p squared, a negative 16, and we want that to add up to a 2p. Well, I've got to have a 3p and a p. That's the only way to get 3p squared. And then let's start trying to see here what might work. To get 16, the first numbers I think of are 2 and 8. But I want it to be negative. So I'm going to make this smaller one negative because I want the sum of these, I want these to add up to give me a 2p. And right now this is going to be 8p and a negative 6p. And yes, those do combine to give us a 2p. So we are good to go here. We've got 3p plus 8. And that's going to be set equal to 0, as well as the p minus 2 equal to 0. So that's 3p equals 8, or p equals 8 over 3, and p equals 2. So with those two values, we want to go back up and check and see, are those going to make my denominator equal to 0 at any point? Looking at this denominator here, p minus 2, if I actually plugged in a 2 right here, 2 minus 2 would make this 0. So I have just found that this actually cannot be a value. The only value that will be allowed is 8/3. Because it will not make our denominator equal to 0. So the only value here that is a solution is 8/3. All right, so that was about the most challenging kind that we can see. Let's look at this last one here. Looking at this one, again, we want to use our least common denominator. There really is just one value here that we have in our denominator. It's just to multiply by x plus 3. So let's do that. We multiply the first one, so we have x plus 6 times the x plus 3, and that is over the x plus 3. Then I have my 2 being multiplied with x plus 3. Subtracting from that, my 5x plus 12, which is being multiplied with my x plus 3. That is over the x plus 3. Now these are going to simplify so that right here on the left-hand side, all I'm left with is x plus 6. Here I'm going to go ahead and distribute this out. It would be a 2x plus 6. And then over here, that simplifies. So I'm subtracting 5x and also subtracting 12. So that would be minus 12. All right, let's just clean this up a little bit. This is nice. Let's see. I've got some terms right here on the same side that can combine. This is going to just come down. But on this side, I've got a negative 3x. See how these two combine to give us a negative 3x. And then my 6 and my 12 are going to combine to give me a negative 6. And let's continue to simplify here, or to solve for x, I should say. We want to move our lesser variable, so I'm going to add 3x on each side. That's going to give me 4x plus 6 equals a negative 6. And then I'm going to subtract 6 on each side. That's going to give me 4x equals a negative 12. Then divide by 4 on each side, and that gives me x equals negative 3. So let's just go back and check like it says in blue. Remember, you can't have values that make your denominator equal to 0. So if I plug in a negative 3 and then add 3 to that, Oh no, that's going to zero it out. It actually does the same thing over here. Zeroes that out. And so what we've just found here is that because the only value that we were able to find actually makes this not work, this is a case where we have no solution because there are no values that when we solve make this true. There's no solution to this equation. What a sad fact that there's no answer, other than to say that there is no answer. I don't know, I kind of like that sometimes. Ladies and gentlemen, that's it for this video where we were using the least common denominator. If you had any questions, would you please take a moment and share those now? And until next time, stay fired up, y'all.